I made a question. So I said the indirect utility function represents our preferences with respect to price vectors. One can say preferences with respect to supermarkets, but not always faithfully. I will tell you why. So we say if we have two price vectors, P, Q, and V of P is strictly greater than V of Q, no doubt, I prefer V to Q. But what is if V of P is equal to V of Q? Will we necessarily be indifferent between the two? What do you think? The answer is no. Why not? Because look at the definition. V of P is the supremum of U of X, our utility function, subject to the budget constraint. And the same, of course, for V of Q. But what if the supremum here is attained and here is not? The supremum are the same, but one of them is attained and the other is not. This means if the one which is attained is the first one, I can obtain the utility V of P by choosing the maximizer. But if the supremum here is not attained, then I cannot. I can go as close to V of Q as I want, but I cannot get V of Q. So then I should prefer P to Q, not to be indifferent. You will say, well, this is a subtlety because if I can approach V of Q as much as I want, I don't care if I cannot get exactly V of Q or V of P, which is the same. But this is not an acceptable argument, because remember that the values of the utility function are meaningless. What only matters is the difference between values. So saying the difference between the U of X I can achieve and V of Q is arbitrarily small, economically is totally meaningless. Let me be more specific. Suppose, to give an example, V of P and V of Q are both equal to 1. Okay? Under P I can obtain this one. So there is, let's say, a point Y such that you will see that V prime of P and is strictly greater than V prime of Q, and you would never say that you are indifferent between P and Q. You would definitely go to the supermarket where prices are represented by P, and will avoid going to the one where the prices are represented by Q. So it depends on the utility function, the equality. Another objection you can make, okay, good, but this is because you are using a discontinuous utility function, which I don't like. Well, we accepted upper semi-continuous, but if you make this objection, then I will ask, how do you know that H composed with U is discontinuous? Maybe U was discontinuous, and you made it continuous after composing it with a discontinuous function. So continuity cannot be an objection here. A more reasonable objection would be, okay, but if prices are strictly positive, then the budget set is compact, and then the supremum is attained. Okay, so this discrepancy cannot appear if both P and Q are strictly positive vectors, because in such a case, the supremum is attained in both cases. Okay, so from this point of view, then I agree, it's a subtlety. I mean, we are only considering the case when some good is free. But still, we are accepting this in the theory. And then this suggests, also leaving aside this very particular phenomenon, can we extend our theory to the case when our preferences are not represented by a utility function? This makes sense, not only because of this example, but also because we know that there are total preorders which are not representable by utility functions. I gave an example, the lexicographical order. Okay? Then it makes sense to try to extend our theory to preferences without utility functions. And I did this together with a friend of mine, a very prestigious Spanish economist, Manuel Santos, who has worked in different universities in Madrid. It worked in my university, my current university. Actually, he who hired me. But then he left exactly the day I arrived. Not because I arrived, that was not the reason for his escaping, but it was a coincidence. In fact, I took his office. He was in Madrid, in a very prestigious for economics Universidad Carlos III, Charles III, but then he has been, his PhD is from Chicago, and he has been in many prestigious American universities, including Minnesota, Arizona. My last news, we are friends, but I have no news from him since maybe 7 years ago, maybe. And in those times, he was at the University of Miami in the US. Very good economist. He has, I think, several papers published in Econometrica, which is the top journal in economic theory. Top. Okay? Well, then, with him, we wrote a paper in the journal Economic Theory, volume 3, 335, 351 are the pages, and the publication year was 1993. Notice that I have said in the journal Economic Theory. I have not said in the Journal of Economic Theory. That's different. This is the journal ET, Economic Theory, and there is JET, J-E-T, which is a more prestigious journal. Is somehow between Econometrica and ET. But this is a rather good one. In fact, I will confess that we submitted this paper to Econometrica. We were very ambitious. At a time when the editor-in-chief of Econometrica was Andreu Mascolell. I have mentioned him many times, a Spanish economist, and we both know him. But he treated the paper very fairly. He sent it to 3 referees. And one referee was extremely enthusiastic. He said, I have learned a lot referring this paper, it's fantastic, it must be published. Second referee said, it's okay. No enthusiasm, but I recommend publication. And third referee said, it's okay, but too technical for the readers of Econometrica. So this was the opinion that prevailed, and the paper got rejected. I mean, I'm telling you, don't feel discouraged, disappointed when you get one of your papers rejected. This has happened to me many times, and I'm proud of it because this means I have submitted many papers. If you don't want, if you cannot accept a rejection, don't submit papers. That's the only way. Okay, but simultaneously to the moment when you are submitting the paper, you must be ready for rejection. Okay? And remember, there was some philosopher who said how to distinguish a person who is worth, who has some value, from a person who has no value. A person who has some value is a person who soon recovers from his or her failures and successes. And a person with no value is a person who never recovers from his or her successes. Sometimes a success is hard to recover from. Okay. Well, so in the end, it was published in a sufficiently good journal, so we are happy for this. But really, the third referee was right. It was too technical, as you are going to see. And don't ask me to give the proofs. But you can find this paper online. This is a journal published, belonging to Springer Verlag. And if you have no access to it, I can send an electronic copy to whoever is interested, okay? No problem with it. So in this, what we did in this paper is, okay, we don't have utility functions. We are not going to use them, but we have a total preorder on R plus n, which represents our preferences. And, well, when you have utility functions, we define the indirect utility function. Now we have to define the indirect preorder. So this will be a preorder defined on price vectors. But now the space of commodity bundles and the space of price vectors is the same. So is the relation defined on R plus n as follows. Given to price vectors, P1 and P2. Okay, when would you say that P1 is preferred to P2? Okay, if your preferences or commodity bundles are represented by this total pre-order. Inspired by what we have just seen, you will say that you prefer P1 to P2 if you can obtain under P1 something which is at least as good as what you could obtain under P2. Okay? Something which is better or equal, in the sense of indifference, something which is better than everything you can obtain under P2. In this supermarket, you can get something, given your budget constraint, which is better than or indifferent to whatever you can obtain in the other supermarket, then you definitely choose the first one. So this is what I'm going to define here. For every, if there exists or but this does not necessarily hold always. In fact, the right definition is not the one I was suggesting, but another one which looks similar but is not equivalent. So if for everything you can obtain in supermarket 2, you cannot obtain something equivalent or better in supermarket 1, then you prefer supermarket 1. I was not giving the right definition. So if for every x which is compatible under P2, I want to introduce some notation because I don't want to write all the time for every x such that P2x is less than or equal to 1. So in order to avoid writing too much, I'm going to use the following notation. I mean, the first definition I was giving was not correct because it was somehow implying that there is an optimal commodity bundle under X1, under P1, which is not necessarily the case in general. So, well, now, going back to notation, I'm going to consider the set-valued mapping from prices into commodity bundles defined by V of P is the set of bundles such that which are compatible with these prices, okay? So we call V of P the budget set, the commodity bundles that are affordable under prices P. And then we can consider the inverse set valued mapping, which assigns to X the same, but now interchanging the roles. Okay, so here you fix the prices and then consider commodity bundles compatible with those prices. Here you fix a commodity bundle and consider the prices under which that commodity bundle is affordable. As I said, the first set is called the budget set under P. The second set is called the inverse budget set. Well then, for every x, call it x2, in B of P2, there exists E1 in B of P1 such that x1 is at least as good as x2. This is the correct definition I already gave. Everything you can obtain in supermarket 2 can be improved upon by something that you can buy in supermarket 1. Okay? And then it's not a difficult exercise at all to prove that this is a total preorder. The fact that it is a preorder is quite clear, is a real exercise. The fact that it's total requires a little bit of careful thinking, but no difficulty. It's also a total preorder. Okay, now you have moved from direct preorder to indirect preorder, which was like moving from direct utility functions to indirect utility functions. But then the duality between direct and indirect utility functions was based on a formula which, under regularity, produced the duality, the utility function from the indirect utility function. So now we need a corresponding formula, corresponding definition for moving from a total preorder on prices to a total preorder on commodity bundles. And remember, B was obtained from U by a subformula, but U was obtained from B by an in formula. So we cannot apply the same definition when moving from preorders on prices to preorders on commodity bundles. We have to make an adaptation corresponding to the replacement of sub with inf. So now let star be a total preorder on R plus n. Now looking at R plus n as a set of price vectors, not as a set of commodity bundles. This is why I write this star, to make this distinction clear. Don't be confused. This X star doesn't mean that we had this and then we construct it in some way and associate it preorder with the star as a superindex. This is just our given preorder on prices. There is nothing behind. Well, there is nothing behind, really. Okay? Then, from this, in the same way as when I have a function on prices, then I construct the indirect utility function, the direct utility function. Initially, we didn't have preferences on commodity bundles, okay? Then, now, I will tell you the corresponding step from V to U. Now it will be from this total preorder into something I'm going to call the preorder with a D with a superindex, meaning the direct preferences, D direct, induced by this total preorder on prices. So it's similar as it is done here. So we define it on R plus N. Looking at R plus N now at a set of commodity bundles, okay, our initial preorder is on prices. With it, I associate a preorder on commodity bundles. Then, two commodity bundles, X1, X2, I will say that I prefer the first one to the second one if something similar with what happens here, but you will see the difference. Here is for every x, 2. Now it will be for every p, 1. Reflecting the change from supremum to infimum. For every p1 in b minus 1 of x1, so which is compatible with this x1, there exists p2 in b minus 1 of x2 such that P1 is preferred to P2. So here it was, for everything compatible with P2, I can find something better compatible with P1. Okay? But here is for everything compatible with, no, this is not correct. This is what I have here, but this cannot be correct. This is what I wrote here, looking at the paper, but I don't agree now. Let me try to correct, let me think. Or maybe it's correct, but I'm not sure. It sounds strange now to me. If there is something worse, in compatible with x2, I forget this x2. So this should not be the case. So when do I prefer x1, or maybe it's correct, no? For each, but then we are back with this definition, and this cannot be the same. No, maybe it is correct. I mean, what happens with a utility function? When Vp 1 is greater, let's say, than V of P2, when or equal, when for every x2 compatible with P2, suppose we have a strict inequality, I'm just getting inspiration in the functions, there exists x1 in V of P1, which is better. Okay, this is what I am writing here. But now what is the meaning that u, if I use this formula, u of x1 is greater than u of x2. Here I was using the definition of V as a supremum, and here I need to use the expression of u as an infimum. Okay? So here I said I was considering the smallest, I should be considering now the largest, and then I would say for every x1 in V of P1, what happens? That V of P, because this is an infimum, is greater than all this. So for every x2 there is something better in P1, and for every x1 there is something worse. No, it was correct. It looked surprising to me, but should not. I mean, this means if this is greater and this is the infimum, the only thing I can say is that there is something smaller here, so there exists. No, it was correct. I copied correctly, but now it looked a little bit strange to me. So it was correct. Okay? And now, I mean, if you succeeded to prove that this is a total preorder, then you will have no troubles to prove that it is a total preorder too. Now the question is, when do we have duality? I mean, if I start with a total pre-order, I compute the associated indirect pre-order, and then I go back by using this definition to a pre-order on commodity bundles. When do I recover the initial pre-order? And this is a theorem you are not going to like, I warn you, because it has a complicated statement. So the theorem says, let this be a total pre-order on R plus n. Then the second iterate coincides with, is equal to the initial pre-order, if and only if the following properties hold. There is an important difference between this case and the case with functions, which made me waste a lot of time and created an obsession in my mind. I was about to become mad because I was trying to find a proof of this theorem and I had a proof already, but what was, I didn't have a proof, but it was somehow implicit. But what was the problem? That again, I was obsessed in following the same pattern as with functions. And with functions, it's equivalent to have a characterization of indirect utility functions than having this duality relationship. Here not. Here we don't have a characterization of indirect preorders. So don't ask me to give you a theorem. It doesn't exist. I don't mean it cannot be obtained, but I cannot. This is what I can say. Don't ask me any theorem of the type, given a preorder on prices, there exists a total preorder on commodity bundles that has your given preorder as the associated indirect preorder, if and only if it satisfies these properties. I don't have such a characterization. But we have a characterization of this equality. Why the situation is different, I will tell you later. Okay? So I wanted to obtain this as a side product of a result I couldn't obtain. This obsession was in 1990, which was the year that the World Conference, most important on economics, the Econometrica conference, was held in Barcelona. The organizers were who were about to be my new colleagues. Okay, a big conference. And I remember I was walking to the conference place, obsessed with this problem. And then it was in June, I think, 1990, and in October I moved to my Department of Economics. During the conference, I was still in UB, not UAB, University of Barcelona, in the Department of Applied Mathematics. Good. Then, what are the conditions that are equivalent to this? Satisfies the following conditions. First, the preorder is non-decreasing. In the sense that more is better. If x is greater than or equal to y, component-wise, then x is at least as good as y. In mathematical terminology, this is an extension of the partial order relation, component-wise order relation, okay? This is the meaning of non-increasing, which we have already used. Second, I said you wouldn't like, but for the time you are liking. But you will start to dislike from now on. No, this one you will still like. For every x1 in R plus n, the set so it's for every the set of bundles that are at least as good as x1, what is called in economics the upper contour set, which is basic, if there is a utility function, is the upper level set, okay? Corresponding to the level u of x1, if u is a utility function. Well, this upper contour set, every upper contour set is evenly convex. Well, you still may like it because you learned yesterday what an evenly convex set is. There are only two properties left. You like it, but a little bit less than A. You will not like C at all. Not to say D. C is for every x1 in R plus n and every alpha strictly greater than 1 and every, if you have an element in the closure of this upper contour set, then when you multiply this x2 with alpha, the resulting vector is not only in this closure, but in this set itself. Okay? Well, not so unpleasant. But this is the real technical condition. If you have two elements in R plus n, which are indifferent, and x1 is a maximal element of maximal in the sense of our preorder, is a maximal element in B of P1 for some P1, So it is optimal for some prices. Then this equivalent commodity bundle, this means for every equivalent commodity bundle, is a maximal element. I mean, to make this clear, let's say maximal with respect to this order, okay? Pre-order. Of B of P2 for some P2. So if some commodity bundle is optimal, maximal, is maximal under some prices, then for every equivalent commodity bundle, every equivalent commodity bundle is also maximal for some other price vector. Then so this is if and only if. And if this property is whole, then what can we say about the indirect pre-order associated to this so nice pre-order that can be recovered from its indirect pre-order? So then we can say that it satisfies property A prime, which is, roughly speaking, this one changing the sign also here. All these properties. It satisfies all these properties with reversing the order. So is non-decreasing, non-increasing, so in the sense that a smaller price vector is preferred. Second, B prime, for every P1 in R plus N and alpha greater than 1. By the way, this property, little bit strange property, C, is reminiscent and is related to what I told you yesterday about the characterization of indirect utility functions. That strange condition with the limit when alpha goes to 1 from the left, involving the lower semi-continuous hole, etc. This is, let's say, the corresponding version with preferences. So alpha greater than 1, and then if P2 belongs to the closure of the set of P in R plus N, so now we are reversing the order. Okay, if you compare with here, so it's the set of P in Rn such that P1 is preferred to P. So P is in the right-hand side. Then P1 is preferred to alpha P2. To alpha, yes, to alpha P2. This is C prime. I forgot B prime. B prime is, as you can imagine, for every P1 in R plus N, the set, the lower contour set is evenly convex. Okay? Here is upper contour set, there is lower contour set, corresponding to lower level sets in the case of a utility function. And now property D prime is the counterpart of D, of course, is for every P1 and P2 in R plus N, if P1 is indifference with respect to the order relation with the indirect order relation, P2, and now we were talking about maximal elements. Now we will talk about minimal elements. And P1 is a minimal in the sense of the preorder we are considering now, which is the indirect relation. It's a minimal element of the inverse budget set for some commodity bundle then the equivalent vector P2 is also minimal for some other commodity bundle. And the conclusion is that the mapping that assigns to a total preorder the associated indirect preorder is a bijection from the set of total preorders satisfying A, B, C, D onto the set of total preorders satisfying A prime, B prime, C prime, D prime. And the inverse mapping is the one that sends a preorder on prices into the direct preorder we associated with it by that definition. I will tell you another interesting fact, and then we stop because in the next hour I will change the topic, going to more conventional stuff. But then look at what happened in the case of utility functions. You start with a utility function, a crazy one, I don't care. You then compute the indirect utility function. Okay? Then from it, you compute what I call U-naught. Another utility function that is equivalent to U in that it produces the same B. So it produces the same B. So 1, 2, 3 iterations. At the third iteration, you obtain the same as in the first iteration. This is typical in Galois correspondences between complete lattices. Okay, if you are not familiar with it, I'm not either. But, I mean, you may be familiar with conjugate functions in convex analysis. You start with an arbitrary function, not necessarily convex. You compute its conjugate. The second conjugate coincides with f if and only if f is convex, lower semi-continuous, and proper. But if it is not, then not. But then if you take the third conjugate, then you always get the same as the first conjugate. Okay, 3 iterations are enough. Here not. I start with a preorder, and I compute the indirect preorder, the direct preorder associated to the indirect preorder by our formula, and to this one, the indirect preorder. We give examples in our paper so that this is different from the first iterate. Very surprising to us. Okay? Because it's not a Galois correspondence. But we were expecting to have this kind of property, and this is the difficulty behind finding a characterization of indirect preorders. Okay? But then the question is, can we continue iterating forever? What do you think? The answer is no. If you do it once more, you will get the same as at the second iterate. So 3 is not enough, but 4 is. Everything is proved in that technical paper that was rejected by Econometrica, and now you can easily understand that the third referee was correct. The paper is too technical for our readers. Okay? So let's stop here, and I will completely change the topic. But a comment is that we were not the first to consider preferences without utility representations. There were a couple of papers before we published this one, but they didn't do anything related to what we did. Okay? Well, thank you. We stop here. So, any problem today?